Okay, so as a recap, we're going to go through all the different exponent laws that we've looked at so far. There are two things I need to do with you before our quiz. That's going to be on Wednesday and Thursday. Before now, we will focus on these exponent laws. Number one, if you have some base to the power of something, and I'm multiplying it with the same base to the power of something else, what happens to the exponents? Recap from yesterday. Okay. The exponents are added. For example, I'm going to be a little annoying here. If I had 9 to the power of 11 multiplied by 9 to the power of -1, you will still add these two numbers. You get yourself 9 to the power of 10. Michael, grab a sheet. Next, if I have some base, let's do m, to the power of a divided by m, the same base to the power of b, what happens to the exponents? It's by sheer logic, you should be able to figure it out. If I'm multiplying, the exponents happen to add. If I'm dividing, the exponents will probably, So this is m, a minus b. So for example, if I have 7 to the power of 8 divided by 7 to the power of 4, or I could say 7 to the power of 8 divided by 7 to the power of 4, that will be 7 to the power of 4, 8 minus 4. Okay. We did two more things. If I had, I don't know, what's a letter that I can use? A z to the power of p, and that is to the power of q. If you have a power of a power, the exponents will multiply. So here I am adding the exponents, here I am multiplying the exponents. So see, so if I had, I don't know, give me a number, 11 to the power of 2 to the power of 4. I am not adding this. It is 11 to the power of 2 times 4. It is 8, not 6. And lastly, I'm just going to be just silly here. If I have a, b, c squared, d to the power of 11, e to the 99f, all to the power of 0. It doesn't matter what the base is. Anything to the power of 0 is. Yeah. Don't be fooled. Okay. If I give you an exponent of 0, it means I'm giving you an easy way out. Okay. You can automatically assume whatever that power is, it's going to equal to a 1. Like for example, if I said, 2xy squared, and that's all to the power of 2, but all of that is all to the power of 0. It doesn't matter what the inside is. That's going to equal a 1. So we looked at the reasoning and the why behind these exponent laws. These aren't made up. These laws were there to make your life easier, because you can imagine, do you want to deal with this big one or do you want to deal with the 1, right? Do you want to deal with this kind of messy power or do you want to deal with a single power? That was the essence behind it all. So we're going to move on to some of the practice questions that I asked you to do for homework. And then we're going to do some of the questions I didn't ask you to do for homework. Okay. So as a practice, a couple of people who are on. As practice, I'd like you to turn to the back of the second page, number 5. We're starting to get into situations where you have more than one variable, more than one power involved in your expression. And simplify. Once again, I remind you, you are not trying to solve for a specific number. You're trying to turn it into a single power, trying to simplify. Look at number 5. I did see with you yesterday, but I'm wondering how many people actually remember. So I'm going to try number 5, A and B, and then we'll move on to some of the more multi-step questions where you have to use more than one law to solve it. Okay, here we go. Going to our handout. Number 5. Using the 4 exponent laws, simplify. Don't solve because you can't. Welcome. Simplify. Part A. If I were to write this out, at first, let's use the exponent laws. Assuming that you're super comfortable, you would see that I have a to the power of 4 multiplying with a to the power of 1. I also have b to the power of 5 and b to the power of 3. I have color-coded these like so because they have the same base. When you have the same base, you can use exponent laws. By default, the answer to this is automatically a to the power of 5, b to the power of 8. Why? Based on your logic, why does that make sense? And then I'll try to defend your logic by opening this up and making it into a long question. Eric? Wouldn't it be e to the power of 7? Can you explain?
Because with multiply, isn't it adding the experiment on?
Hey, good catch. Thank you for that. That 3 right there actually only applies to the B. Yeah, the A is actually to the power of 1, right? So that's a good catch. And let me try to explain so that, my explanation will cover that too. So take a look at this. A to the power of 4 times B to the power of 5 times a to the power of 1, b to the power of 3 is actually the same as saying this. A to the power of 4 is multiplied with a to the power of 5, which is multiplying with a, which is multiplying with b3. Do you see it now?
No, I understand.
Yeah. And here's my defense of why this can go into my previous answer. If I were to open this up, it's the same as A, B, 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 A, B, B, B. These are all multiplying with each other. So how many A's are actually multiplying with each other? So I'll try to color code it again. A to the power of 4 is this part. The A is that part. So it's a to the power of 5. B to the power of 5 is this part. And then b to the power of 3 is this part. Michael, let's get off. So it's your problem, it's not mine. Okay, there it is. So in your head, as opposed to knowing that you're supposed to multiply it all out, what's a shortcut that you can adopt? I'm doing a division now. What is something that you can adopt instead? Seeing as how we were able to do this, right? Can you go from one line to the next in one shot? Take a guess. Yeah. Correct. That is division. Correct. How did you get that? Correct. That's it. That's it. The reason why I'm asking you to do these questions is as we move further, the whole purpose, I guess, for this section is to try to give you as complex an expression as possible so that you can simplify it. Are you going to be using complex expressions in the future all the time? Absolutely not. But again, it's trying to get you to see how well you can follow a system, right? And the more complex it is, the more thinking that you have to do. So think of it as a puzzle. Here's an example. Example 5. Okay. Let's just do the harder ones. Just go straight up and do the harder ones. F. A to the power of 7 times a to the power of 3, all divided by a to the power of 6 times a to the power of 2. So, number 1, are the bases the same? Yeah. Can we use the exponent laws? Yeah. Go for it. I have a to the power of, I'll give you a hint. Please do the numerator and the denominator first. It's not that you have to, because all you have here is multiplication, division. But if you ever get a fraction with addition and subtraction and stuff like that, I'm just scared that you'll make unnecessary mistakes. So try that first. What's the numerator? Micah, get off. Okay, come on. Someone else. Let's go. Exponent laws. They're multiplying. Quick. Cameron?
10.
Yes. 8 to the power of 10. Good. Denominator? Good. And so? Yeah. Multi-step. Trying to be tricky. But if you know your exponent laws, it shouldn't be that bad. Let's move on. How about number 6, F? Careful. Now I'm using all 3 laws. You'll see what I mean. Look carefully. Let's attempt the numerator first. Someone else? There you go, Nessica. Yep. Correct. Over? Correct. Good. 7 and 3, it's a power of a power. Exponent law 3, you're supposed to multiply. And if you're not convinced of that, that's 4 to the power of 7 multiplied with itself 3 times. So 7 plus 7 plus 7. It's like 7 times 3. 21. Not 4 to the power of 9 times 4 to the power of 11 means the exponents are going to add. So you see how it can be, I'm trying to throw you off, making sure that you know what to do in different circumstances. Now 4 to the power of 21 divided by 420. 4 to the power of 1. So I just write 4. Again, not trying to be quote unquote that tricky, but it does require you to have some knowledge and some practice with this stuff. Okay, simplify writing as a simple power. How about D? Now I'm just getting extra annoying with you, right? Actually, you may not have seen an example like C. Let's do C. I'm gonna give you, let's see how much time you would need. I'm gonna give you a minute. See how far you can go. And remember, people can do this differently. You could do exponent law 3 before 1. You could do 1 before 3. It's a matter of what you think is most appropriate. So I'll give you a minute, then pause the video. Can you tell me what you tried for part C? And if we're comfortable here, I'm gonna move on and jump to number 10. I think that's today's lesson, and we're done. Yep, go ahead. I don't know, but you said 13 to the power of? 10? Okay, let's check it out. How did you get that?
Well, 13 to the power of 6
Mm-hmm.
times 13 to the power of 2. That's wrong.
Perfect. So you decided to do inside the bracket. I like that. Okay. Simplifying inside the brackets also happens to follow BEDMAS. That's great. And that is 13 to the power of 7. Okay. What's next? They're added together because this is multiplying. Yes. But keep going. Okay, so this is 13 to the power of 26. Good. Over power of
14.
Yeah, good. I like that. This 2 means that this entire fraction multiplies with itself. So it means the 13 is multiplied by the 2 and the 7 is also multiplied by the 2. If you don't believe me, think about it this way. 13 to the power of 3 over 13 to the power of 7 times 13 to the power of 13 and 13 to the power of 7. 13 plus 13, 26. 7 plus 7, 14, which means it will be perfect. And this is where the exponent laws come in so handy. Do you want to deal with something like this, right? X to the power of 1 times x to the power of 12, blah, blah, blah. Or do you want to just deal with 1 power? It's simply a matter of making your life easier that we learn these exponent laws. I hope that you're not just memorizing it because I'm telling you that in the math world, it's supposed to be useful. So great. Everyone else, if you're following along, I hope that you see where all this comes from. We are now looking into today's main point. What do you do when, let me make this a little larger. If you're feeling a little sleepy until now, I need you to pay attention now. What to do when bases are different? Okay. And you'll see that as in question 11 as well. So here it is. Number 10a, it's 4 to the power of 3, but I want to write this as 2 to the power of something. This is a skill you will need to solve number 11. So how do you change a power to have a different base? Well, consider this. Would you agree that 4 to the power of 3 is the same as 4 bracket to the power of 3? Yes or no? Nothing different, right? There's nothing different between these two lines. But would you also agree, using your arithmetic knowledge, your multiplication tables, that 4 is the same as 2 times 2? 4 is the same as 2 times 2, or 2 squared. Let me write that. Would you agree 4 is the same as 2 times 2? Which I can rewrite as 2 multiplied with itself twice. And what do you do when you have a power of a power? Show me a symbol of what you're supposed to do. Multiply, good. 4 to the power of 3 is the same as 2 to the power of 6. And you will need to be able to change the base like this for the next question. So let's try this one more time. Let's do B. 9 to the power of 5, I want to write it as a base of 3. Would you agree, though, that 9 can be written in terms of 3s? What's a 9? Careful, 9 would be 3 times 3, correct? Which is actually 3 to the power of 2. So yeah, exponents are a different system altogether. So you have to be careful 3 to the power of 3 is not 3 times 3. So 3 to the power of 2 to the power of 5. What do you do with powers of powers? This is 3 to the power of. Okay, stay on top of it. It starts to get a little tricky. I am going to show you C and then D and then even E. Okay? All of these questions are worthwhile. Part C. 27 to the power of 5, I want to write it as a base of 3. So what the heck is 27 in terms of 3s? Yeah. It would be 3 times 3, which is 9, times 3. 9 times 3 is 27. So suddenly your exponent, your multiplication tables suddenly become really useful. So I can rewrite this as 3 to the power of 3 to the power of 5, which is 1. So again, you're going to see this later on. Number 11, for example, I am using different bases and I'm still asking you to solve it. Yep. Okay, come back quickly, please. All right. Let's try a hard one. Ready? D. Negative 8 to the power of 4. I want it in terms of negative 2. So what is negative 8 in terms of negative 2's? We'll just count it out. Negative 2 times negative 2. Am I there yet? What's negative 2 times negative 2? Positive 4. I'm not there yet. Let's do it one more time. Multiply that by another negative 2. What is 4 times a negative 2? Negative 8. We got there. So I know it's 3 times. This is the same as saying, I'm going to do double brackets. So this is to the power of 4, right? The inside I can rewrite as negative 2 to the power of 3. Negative 2 times negative 2 times negative 2. And so if I simplify it, this is negative 2 to the power of 12. Negative 8 to the power of 4 is the same as negative 2 to the power of 12. What about E? Last one before I move on. I want to rewrite 1 over 4 in terms of 1 over 2. When in doubt, just start multiplying if you're not sure. To me, I see it because I know my multiplication tables, but you might be thrown off just because it's fractions. Give it a shot. 1 over 2 times 1 over 2. Am I there yet? Try it. 1 over 2 times 1 over 2 is 1 times 1, multiply across, 2 times 2, multiply across. Am I there? Did I find it? Yeah. So this is the same as 1 over 2 squared to the power of 3. The final answer is 1 over 2 to the power of 6, this power of power. He keeps going. He keeps going like this. So let's say on the Friday's quiz, I give you a question like 11A or B. Can you do it? Clear? Let's do A together. This is for The people in the back who can't quite see. All right, I have exponent laws to use. Are the bases the same? You see where that skill comes from? You can still simplify. It's absolutely possible. Before I do that, I need all of these to have the same base, which comes to the human element of this. What base do you think is most appropriate? Yeah. And that comes from experience. Why do you say 2? Well, don't just think they're visible. From our previous homework, previous thing, you know that 4 can be written as an exponent with base 2. Right? We've learned this. So if this can be turned into a base of 2, and that is already a base of 2, we can use exponent laws like normal. So again, the whole goal of this exercise is supposed to make your life easy. It's not supposed to stress you out because you have to memorize new things. But the teacher is saying that, so clearly you don't have to believe me, right? Here we go. Changing this. If you don't like doing it on the fly, let's bring this aside. Let's turn this into a base of 2. What is 4 in terms of 2? What, 2 times 2 times 2 times, how many times do I multiply to get a 4? Yeah, this would be 2 times 2. So instead of writing it out, I'm just going to go straight. I think you can handle that. 2 to the power of 2 is the same as 2 times 2. And so that is equal to 2 to the power of 4. This expression, I can rewrite it as 2 to the power of 2, which is to the power of 3, divided by 2 to the power of 4. And solve. Yeah. 2 times 3, that's 2 to the power of 6, which is 2 to the power of 2. So these are just techniques. I won't even call it pure math. It's techniques. It's arithmetic. It helps you with simplifying things. And it's all based on practice. As I said, this is sort of like the extent of the T questions you might be asked on Friday. It's all just a matter of practice. Sometime today, as you work through this, I hope that you get a chance to do enough practice that you can try number 13 and 14. That will take you to a new level of understanding if you can do that. So give this a shot. Give all of these questions a shot, all the way from number 5 in the previous page, up there, number 5 in the previous page, all the way down to 14. So got over 35 minutes. I hope you get a chance, because tomorrow we're going to go into the exponent law number 6. What happens if we have a negative exponent? So we got to learn that to make sure we're well-rounded. Yes, absolutely. Any other questions? I'll leave this up here so that you can take a look at it, at which point I will pause the video, and everyone else, let's get to practicing.